In today's class, we'll be looking at the Argand diagram, which is also called Argand plane, or we call it what? Complex plane. Now, Argand diagram is a diagram that represents the complex number. Any diagram that represents complex number is called what? Argand diagram. From our diagram, we have our line OP, which is our resultant. We have our vertical line, which is what? Y, and we have our X, which represents our horizontal line. Now from here, and we also have alpha, which our alpha is called the argument, or we call it the amplitude of Z. Now recall, my Z equals what? Z equals X plus IY, where we've said already that X and Y are real numbers. X represents real, Y represents what? The imaginary part. From there, we now have what? We have our R to be equals what? The modulus of Z. That's our resultant here. To be what? The modulus of Z in this case, which is the same thing as what? Modulus of what? X plus IY. Why? Because my Z is what? X plus IY. And in this case, finding modulus becomes what? Square root of what? The real part plus the imaginary part, what? Squares individually. Okay. Now, Z times Z conjugate, just take note. Z times Z conjugate is equals to what? X plus IY times what? X minus IY, which is the same thing as what? S squared plus what? Y squared. And that becomes what? Modulus of what? Z all squared. If I say my modulus of Z is this, it means the square of this becomes what? This. That is, this will cancel what? The square root here. Okay, and let's see what we have then before we solve a particular question on the Argand diagram. From our diagram, we have our X to be what? To be R cos what? Cos alpha. If I was to find X, I'll be relating X with our resultant and alpha. So what's the relationship? This is our what? Adjacent, this is our what? Hypotenuse. That's cos. So when you do the manipulation, you're going to get our X equals to this. For our Y from the diagram, it's the same thing as what? R sine what? Sine alpha. And for our tan alpha, we have our Y over X equals what? Tan alpha, or tan alpha equals Y over X, where we can see that what? Sine over cos is tan. So I have Y over X equals what? R cancel R. I have sine over cos, which is what? Tan. Okay, and also in that case, then alpha now becomes what? Tan inverse of what? Y over X. That's from here. If Y over X equals tan alpha, or if tan alpha equals what? Y over X, my alpha now becomes what? Tan inverse of what? Y over X. Now let's see this question. Given that we have the first question as what? Z equals 7i minus 2. In this case, my X represents what? My X is minus 2, because this is the real part. My Y is what? Is 7. I'm to find the modulus or moduli and what? The argument of this question. Okay, I'm to find modulus and what? Argument of this question. Okay, from here I said my alpha represents what? Argument of Z, which implies that I can say that my what? Alpha equals what? Arg Z. Alpha also equals what? Tan inverse of what? Y over X. That's from this point here. That's this point. So let's solve for my modulus and what? Argument. Now, how will I get it? Modulus of Z, which is the same thing as what? My R, becomes what? The square root of my real square, that's minus 2 all squared plus what? 7 all what? Squared, which is the same thing as what? 4 plus what? 49, which is the same thing as square root of what? 53. Square root of 53 now gives us what? 7.28 when you find the square root of 53. Now this is my what? This is my modulus, mod Z. Okay. Now, For the argument now, argz, remember argz is the same thing as what? Tan inverse of what? Y over z over x. Okay, which is going to be what? Tan inverse of what? My y in the question is what? Is 7. X is what? Minus 2. So it means I will find what? Tan inverse of what? Minus 7 over what? 2. After finding it, I'm going to get what? 74.1 degree. How will you find this? Ignore the minus. Find the tan inverse of what? 7 over positive 2. I'm going to get what? 74.1 degrees. Then for this minus, check where tan is negative in your quadrant. All students take Coca-Cola. It is negative here, it is negative here. So let's use, it's negative in sine, it's negative in what? In cos. This is where tan is positive only. So let's use this. The formula is what? 180 minus what? Theta. Remember, we first got the tan inverse of what? 7 over positive 2, which is what? 4.1. Now we want to get what tan is in the negative quadrant because of this minus here. So how do we get that? Very simple. 180 minus theta becomes what? 180 minus this, which now leaves my alpha to be what? To be 105.9 degrees. Okay, so for number 2 question, let's say we're given a question like 7i minus 2 into 3 plus what? 4i. Adding this, I'm going to first get 7 plus 4, that's 11i. As 11i minus 1. Okay, so that's 11i minus what? Minus 1. Now, how do I solve this? So this is the answer. So let's now get what? The modulus of what? Z in that case. Modulus of Z, which is same as modulus of what? 11i minus 1. That becomes what? It becomes square root of what? 11 squared minus what? 1 squared. Which is what? Okay, sorry, I'm to multiply here, isn't it? Oh, I'm to multiply here. I was adding. Now, multiplying, I'm going to have this as what? 7 times 3, that's 21i. 21i plus what? 28i squared minus 6 minus what? 8i. Which now becomes what? It becomes 21i. Okay, this is ti. 21i minus 28 minus 6 minus 8i. On add, I'm going to have this minus this to be what? That's 13i. So I'm going to have my z still to be what? 13i. Okay, 13i. Then minus 28 minus 6, that's what? Minus 34. Minus 34 what? Minus 34 in that case. Okay, so on add, I'm going to have this as what? 21 minus 8, which is what? 13. Minus 28 minus what? 6 is what? Minus 34. So this now becomes my z. Now to find the modulus of z, or the modular of z, I'm going to have that as what? Square root of what? 13 squared plus what? 34 squared. Which now becomes square root of what? 1325. Now, that's after adding the square of 13 and what? 34 together. Now, I'll have this as what? 36.40. That's my what? That's my modulus of z. Now, how will I get the argument of z? I have argz, which is simple as my alpha to be what? To be tan inverse of what? Y over what? X. Remember, my y is what? My y in this case is what? My y in this case is what? Minus. My y is what? 13. My x is what? Minus 34. So I'm going to have that as what? Tan inverse of what? My y is 13 over what? Minus 34 in that case then. Now, after finding the tan inverse of this whole I have, I'll have this as what? I'll have this as 20.9. That's the tan inverse of 13 over 34 in its positive state. Now, remember how I explained a question. You will now look for where tan is negative in the what? In the first quadrant. In the 4 quadrants. And that's what? That's my second quadrant. So, all I now do, my alpha now becomes what? 180 minus theta apply the formula, which becomes 180 minus what? 20.9. Then I have my alpha to be equals to what? My alpha to be equals to 159.1 after subtracting. So this will be the answer. So after finding your modulus, which is simple, find your argument, which is tan inverse of what? Y over x. And from there, you get your answer. If the answer was in positive, that's going to be the answer. But if the answer is in negative, you apply what? The second quadrant, because tan is negative in the second quadrant, by saying what? 180 minus alpha, where my alpha here is what? Is 20.9. So my new alpha now becomes what? 159.1 degrees.